Alright, so for the first question here, for finding the percent composition by mass, what I'm going to do is I'm going to look at my overall amounts here. So in the question you should notice that you're told that the compound has the total mass here, has this much zinc, so 32.69, and 16.03 grams of sulfur. So what I'm going to do to figure out the percent of zinc, so I know the percent zinc is going to equal 32.69 grams, and I got that from up above. And I know my total mass is 48.72 grams, and I got that from above as well. And then once I've done that division, I'm going to multiply by 100. And if I take my calculator and do that, I get 67.098, so I put my 8 there, percent, so I put my percent there as well. And then I know that for the percent sulfur, I know that sulfur is going to equal 16.03 grams divided by 48.72 grams times 100 is going to equal 32.902%. So then you need to make a therefore statement, and you need to have 4 significant digits because you're given 4 significant digits in your answer. So it would be 67.10% zinc and 32.90% sulfur. Moving forward, in this situation, you're required to find the percent composition by mass from the chemical formula. Your chemical formula you're given is hydrogen peroxide, or H2O2. So what you need to do is the first thing you start with is the molar mass, or capital M, of H2O2. You know that's going to equal 34.02 grams per mole, and I did that by doing 2 times 1.01 grams per mole plus 2 times 16.00 grams per mole, and that gives me a grand total of 34.02 grams per mole. Now what I do is I compare for each of the elements within the compound. So I look at the percent hydrogen. I know the percent hydrogen will be, there's 2 atoms of hydrogen in the compound times the molar mass of hydrogen, which is 1.01 grams per mole, divided by the overall molar mass of the compound, which is 34.02 grams per mole. If you're wondering where I got the 2 from, right here, this 2 is from the 2 hydrogens up in my formula that I have. I know that I'm going to take that, and because it's a percent, I must multiply by 100, and my answer comes out to being 5.938%. I'm just running out of room there. For percent oxygen, I follow the same procedure, so 2 times 16.00 grams per mole divided by our overall molar mass of 34.02 grams per mole multiplied by 100 is going to give me 94.06%, and in both situations I think I've listed my answers to 4 significant digits. So I'm ready to move forward to the last example. So now I need to figure out the mass of an element given the mass of the particle. What I know in this question is I have the overall mass of my compound as 60.0 grams. So the first thing I should do is off on the side, and I often do this on the side of my sheet of paper, is I kind of work off to the side to figure out what is the molar mass of calcium bicarbonate? So if I do that off to the side, just believe me when I say it's 162.12 grams per mole. In class I showed how to get that number, but I hope by now you know where I'm getting that, and that would be the molar mass of our compound of calcium hydrogen carbonate. So I got 162.12 grams per mole. So because in this question I only need to find the mass of calcium, I should figure out the amount of calcium, or the percent that calcium represents in this compound. So what I can do is I take calcium's molar mass, which is 40.08 grams per mole. I divide it by the overall molar mass, which I got above, and that's 162.12 grams per mole times 100. And in case you're not sure what I'm figuring out, it's the percent of calcium. And that's going to give me 24.722%. So I take 24.722, and don't forget from grade 9 and 10 math, you can't do math with percents, you have to convert them to decimal. So to find the mass of calcium, you're going to take this as a decimal, so now 24.722% becomes 0.24722 multiplied by the total mass that we have, which is 60.0 grams. And if you're wondering where I got that crazy number from, it's up here in our question. And then I do that multiplication to get 14.83 grams. So that means in the total 60 grams of calcium bicarbonate, or calcium hydrogen carbonate, of that 14.83 grams are calcium. So you can make your therefore statement. Therefore, in 60 grams of calcium hydrogen carbonate, there is, and you can use a little bit more room, I'm kind of getting squashed here, 14.83 grams of calcium. Beautiful.